on this computer. Okay, so so I know that according to my experience at Montclair, I find that most students are not a fan of math. So if you didn't do good in this course, in the math course, it is okay, because in our class the math that I require from you is mostly like high school math, rather than the algebra. So, and but you will need to do so in order for you to be successful in this class. You will be. I hope that you did great in your Java classes, Java 1 and Java 2, because our course involves a lot with programming. It is not a one-off. It is the course. It is just the course with the most programming experience for you at Montclair. So and most importantly, it is so I want you to have the ability to program in Java. Like you need to be able to create your own class by yourself, or a class by yourself, and say define a couple of functions like constructors, and define some statistic methods for a certain class. So let me say. Just let me know if you think that you have that ability already or not. So you can either tap in the chat area or just use your Mac to say something. Yeah, just say yes or no. Do you have the ability to program in Java? Like define a class by yourself and define the function inside that class. Okay, awesome. So yes, okay, great. This will be very useful or helpful for you, especially in the beginning of the course. Because if you, I know that my previous experience as an instructor of this course is that some students are from community colleges, and in their college, the instructors didn't teach Java. Instead, they teach something like C++ or C, and definitely you are going to have some difficulty in the beginning of the class if you don't have a lot of Java experience, Java programming experiences. But I don't require a lot from you in terms of Java programming, as long as you know what is a static function, how to define a class, and how to do how to play with array in Java. You should be good, at least in the beginning of the semester. So this is the pretty much what I need from you in the beginning. And okay, so this is what you should have already have. Do you need OOP? So object-oriented programming. So OOP is, so object-oriented programming is basically the logic, how you design your program. You need to design your program or project by using the logic of oriented, so object-oriented. So in our class, we're not going to have. I'm going to give you a lot of programming homeworks, but each homework is not a big project. So you don't have. So it's not. So let's do it in this way, okay? I'm not going to give you a project like building a whole house or build a big building. I'm just going to, each homework is pretty much like build a level of a big building. So you don't need the logic of object-oriented programming, or you don't have. It's pretty much like if you just want to build a level of the house, you don't need to know too much about architecture. Instead, you need to know more about civil engineering. So yes, you don't need OOP, the design logic. So okay, and next is, so what can you learn from this course? So first, I'm just going to split this in two parts. So the first part is the logic of mainstream data structures and algorithms and complexity analysis of the algorithm. So the first two will be done through lectures. In the lectures, my task is to explain to explain you why these data structures and algorithms work. And I'm going to give you some examples and follow it line by line to explain it to you to make sure that you understand it. Besides, I'm going to go over the complexity analysis of the algorithm with you so that you understand how fast or how slow is a certain algorithm. And and then the third part is, I think this is the most important thing. Okay, it's your coding skills in Java, and this will be up to you. Okay, so let's do it in. Let me explain it in this way. Okay, so for example, if you want to build your muscle, if you want to be a muscle man or a fit lady, so you go to gym, right? And then you find a coach and to teach you how to do some exercise in order to build muscle. And the coach may tell you or may explain to you, okay, you should do the push-ups or how to lift the weights also. And also the coach may tell you, okay, you have to regulate yourself and discipline yourself. You cannot eat junk food. Be healthy. So I'm pretty much like the coach for you. Okay, so I'm going to explain these things to you. But in order for you to really build the muscles, even though I don't have much. In order for you to build the muscles, it's totally up to you. Okay, so you should be the person who discipline yourself and keep going to gym, pay your efforts. So, and if you keep doing that, maybe in 1 year or 2 years, you will be able to get to the place where you want to be. Same here. So I'm going to explain these things to you, but it's totally up to you to practice your programming skills. There is no shortcut to being a good programmer. So when I taught my previous classes, some students asked me, how could I be a programmer as good as you? I said nothing. Practice. If you okay, so because I'm using my iPad Pro now, I cannot share with you my laptop screen. I got a whole bunch of code every day. I'm coding, so that's how I practice that. How I come to be a programmer, which is not too good, but it's okay. Okay, so I'm okay at programming, even though I'm not too good. So same here. Okay, you should pay your efforts, a lot of efforts, in order to be a good programmer. And the last thing is adapt these algorithms to solve practical problems. So we don't have a lot of space for this, because we're like just brushing up your coding skills is a big task. So this thing, for the last thing, we're going to have a little bit of touch with it, but you are mostly going to practice these skills, the last skill, in your 300 level classes. So we're only going to have a little bit of touch of it. So this is what you can learn from this course, and most importantly, it is the coding skills. Okay, and in order to achieve those objectives, I would definitely ask you to do a lot. So the first thing is that we are going to use a textbook. So the name is Introduction to Algorithms, the 3rd edition. So here is a link to the PDF of this book, which is free. So you can use this link to download it. I'm not sure if this link still works because I found it 2 weeks ago. But if this link does not work, you just need to Google this name, the book's name. I'm pretty sure that within 5 minutes you will be able to find a free PDF of this book. And this book is really, really thick. It includes in total there are around 1,200 pages of this book, which is a lot. So my task is I don't, to be honest, I don't like to assign a lot of reading books because we are in the computer science or IT major. We're not in the literature or history major. So in our, I say I emphasize more on skills compared with theories or knowledge. So it is your skills which can make your life rather than the knowledge. So especially when you're young. So here, what I can do is that I'm going to reduce the reading task for you. So instead of reading this 1,200 pages, I'm going to make it 200 pages for you. Okay. So which is roughly around 15 pages a week. So to read 15 pages a week for of this book, you probably need around 2 to 3 hours per week. So the reason why I ask you to read it is that in my when I teach this course, when I explain the data structures and algorithms during the lecture, if you miss one part or if I don't explain one part clearly, you can go over this book and have a very good understanding of it. And actually, it's, even though I think I explained it in a pretty good way, it's very difficult for you to be able to digest all of that just within our class. Your brain is going to burn, and at the end of the class, you feel like your brain is twisted. So your brain is twisted. So it's necessary for you to read the book after our class in order to have a better understanding of the data structures or algorithms. So and plus, what's more important is this. Okay, every week I'm going to give you a programming assignment, a coding assignment, and each assignment usually takes you around 2 to 5 hours, assuming that you have a good, if you have solid Java program skills from your Java 1, Java 2. So just this is the assumption. But say in the beginning, say if you say I haven't programmed in Java for a long time, maybe 3 months, maybe like 3 years, then this time will the amount of time that you are going to spend on the first couple of homeworks will increase dramatically. And so my experience is that on average, the second homework takes you around 10 hours. So be prepared. The second homework it's going to be released the next week, and it's so last year I had a very good student, and he told me that he spent 12 hours just on the second homework, 2 days, two whole afternoons and evenings. So be prepared. I know this is scary, but again, there is no shortcut to be a good programmer. If you want to be someone who looks pretty cool, wear this hoodie and type programs very fluently, you have to pay these efforts. Okay. So okay. Regarding the book, I want to emphasize that even though you can find a free copy of this book online, I strongly suggest you to purchase a hard copy of it. The reason is that, okay, I'm going to tell you the reason. I spent 4 years in my bachelor to earn in my bachelor degree. My bachelor degree is in software engineering, which is pretty much like IT. And I spent 4 years in my bachelor degree plus 5.5 years to earn my PhD. So in total, I spent 9.5 years in college. And through those years, I took this course twice, one in my undergraduate and one in graduate years. And also during that time in total, I took around 50 courses that are related to CS or science or IT. So if you ask me, okay, if you ask me what is the most important course what is the most important course for a fresh undergraduate student to find the first job in the IT or computer science field? Okay, the most important course for you to find your first job in IT. I'm going to give you two answers, which the two most important courses in my mind are data structures and algorithms, plus database. Okay, so yes, if you are good at these two courses, so it won't be too difficult for you to find your first job as a programmer. But if you are not good at that structure or database, I would say mostly likely you are going to leave this field. Mostly likely, okay. You won't have, so it's hard for you to find your first job. Say if you do not do good if you do not learn the data structures or database well, after you go through a couple of job coding interviews, you will be totally disappointed, and then you won't continue apply for jobs anymore. So you are going to hunt for something else. Any question? I hope it seems that someone just want to ask a question. Yes or no? Okay. So if you have questions, so it's better for you to first type in the chat area, and I will be able to read it. Okay. So or say if you want to talk, you just want to you can just type in the chat area, say question, and I will let you raise it. Okay. So for this book, in those 9.5 years, I read this book 5 times. 2 times when I was a student. When I was in my class, and 3 times when I tried to prepare for my coding interviews. Every time I was about to enter the job market, say look for internships or look for full-time jobs. What I did is that I first go over this book to refresh those algorithms and the data structures, and then practice my programming. This period is like 2 or 3 months. Only after that, I'm going to apply for a couple of positions and go through the job interviews. Otherwise, if you're not prepared, and you just apply, it's just a waste of your time and opportunity. So the reason why I strongly suggest you to keep a hard copy of it is because in the future, when you will have to do the same thing. Okay, you have to say refresh. You go through this book before going to a job interview. So if you keep a hard copy of it and make notes on it when we are going through this class, those notes are going to help you a lot when you refresh your knowledge. Okay, so you don't have to, so with those notes, you don't have to read those 1,200 pages. You probably only need to read 50 pages plus your notes, which saves you a lot of time. So it's really worthwhile, and it's only cost you like $35 on Amazon. So personally, I take it as my handbook. So and I still keep that hard copy with me. So because someday if I lose my job at Montclair, I have to go back to the job market, right? So yes, I need to be prepared just in case. So okay, and this is the evaluation. How am I going to evaluate your performance? So we're going to have 3 parts, which are assignments, final projects, and final exams. So the final exam. So the most important thing is just the programming assignments. I'm going to give you a programming assignment every week. In total, there are 10 or 11. I think 10. And each homework, each programming assignment is equally weighted. And so on the right-hand side is how can you translate your numerical grade to letter-based grade. So if your overall grade is higher than or equal to 95%, you will get A. Whereas if your grade is higher than or equal to 90 but lower than 95, so you will get A minus, and etc. So basically every five point means a different ladder-based grade. And if your overall grade is below 60, you will fail this class. So I'm pretty strict with this grading, with grading and with the grade. So which means that if your overall grade is 94.8, you will get A minus, not A, because you are lower than 95. Okay, so and also because actually, so here I'm just explaining to you how to calculate your overall grade, and by following that, after we finish the final exam and I enter your final exam grade on Canvas, you should be able to calculate your overall grade directly, and and also translate that into the ladder-based grade. So after the final exam, I only reply emails regarding to grade if I calculated your grade wrongly. If you think that my calculation is not correct, please contact me. Otherwise, even though you contact me regarding your grades, I'm not going to reply you. I'm just saying after final exam, okay? At that time, everything should be fixed. I'm not going to say if you send me an email, professor, hey professor, can I get a better grade? You get whatever you deserve based on this say calculation, just to be fair to everyone. So I'm not going to open a back door to anyone. So this is our tentative schedule. So even though our semester consists of 14 weeks, I'm only listing the tentative schedule for 13 weeks. I'm going to leave 1 week as the buffer. So just in case that we want to say refresh something, or we want to spend one more week on something. So and here you can see that it's pretty horrifying and scary, right? Every week there is a programming assignment from homework 1 to homework 10, and then following that is the final project. Yes, this is how you practice your programming. And I have to do that. I mean, when I teach some other courses, for example, I also teach the course CSIT 335, which is the operating system. So some of you may take my operating system class later. So if you like me, you can take it. You can take this course with me later. So because in my opinion, this course, the operating system class, is not very it's not very important for you to find your first job. So in that class, it's more like I'm just giving lectures, and there are only 2 homeworks throughout the semester. Each homework is like 1 or 2 hours workload. So, but for this one, for this class, because it's really important, I have to push you. I don't like to push the other people. But for this class, I have to do that, because first, if you don't do good in this class, if after you go to the 300 level classes, all those instructors will assume that you are already a good programmer. They will not teach you programming at all. Instead, they just say, okay, what is software engineering, and what is robotics or human computer interaction. So something like that. So they basically assume that you are already good programmers. So which means that if you are not a good programmer yet, and you go to the 300 level classes, you are going to suffer a lot. And so the other reason is that, okay, so if you don't do good, which is as what I showed previously, okay, if you are not a good programmer, probably you will have to, mostly likely you cannot find the first job as a software engineer or so, and you probably have to leave this field, go to the other industry. I mean, it's absolutely fine if you think that you are not a good fit for this industry, and go for some other choices. But the thing is that since that you have already spent your 4 years, maybe 5 years, plus some tuition on this major, why not just focus on it? Because this 4 years and your tuition already give you an edge in this field. Why are you going to compete with someone else, say with already having a finance degree in finance? So you don't want to do that. My aim is to keep as many students in the field as possible. Okay, so and next is the policy. So I think if we go to the syllabi, the policies will be more straightforward. So okay, so here if our class is taught in a face-to-face format, it will be Tuesdays from at the same time at CCS 149, and this is my office hours. So because of the current situation, we are going to start this class with say synchronous online teaching, and so this is my virtual office hour link. So and the format for me to do teaching is pretty much like that. So first I have my laptop running, which shows with the web camera running on my laptop, and you will be able to see my face. And at the same time, I'm having this one, which is iPad Pro, so with the Apple Pencil, so that I can write a lot of notes on it, and then you will be able to say that it's pretty much like a whiteboard. So and okay, so this course follows the hot mix modality, which means that when we are doing remote learning, it has to be synchronous, meaning that everyone has to join the Zoom meeting altogether. So and also, okay, when the situation allows, we will go back to campus. According to the university's requirement, okay, everyone has to come to campus if we go back to campus, okay? If the class is taught in a face-to-face format, everyone has to go back to campus, and go to the face-to-face teaching. And if you have some health concerns, or if you don't think it's safe, you should contact the disability center and file your request to them. And if they approve, then you will be fine. So so this is the requirement from the university, not from me. And also my plan is that when the daily test positive rate is below 2%, or I mean, in the best case, it's below 1%, we will go back to face-to-face teaching. And I think that by the end, so probably by the end of March or in early April, we should be able to do that. So okay, and sorry, is there a question? Okay, so and of course, if we go back to campus and the situation goes too bad again, then we will transit back to the fully online teaching if it's necessary. Okay, so then some other policies are like here. Okay, so you need to submit your assignments and final project. We don't have lab, but you need to submit your assignments and final project on time. If your submission is late, you will receive a late penalty. The late penalty policy is this: if you are late by 1 day, then you will receive 10% late penalty. 2 days, it's like it's going to be the late penalty is going to be 20%. 3 days, 30%. and larger than 3 days, more than 3 days, 0. Okay, it will be automatically 0. So, but I'm pretty flexible with extensions. Say, I know that everyone has a life, and definitely the life and families are more important than learning. So, or more important than the career. So, say, if you are experiencing some difficult time and you want more time for homework, just send me an email. Briefly explain the reason why you want the extension and how long do you think how long the extension do you want it to be. So I will mostly likely I will approve and give to you. Okay. So but we have to do that if you have to ask for extension before the due date. You cannot ask for it after the due date. Okay. So and also I have zero tolerance of plagiarism or teaching or cheating. So 1 year ago or 1.5 years ago, so 2 students failed this class in the 3rd week. Okay, because of cheating. When I graded their first homework, I found it, and after going through a certain process, they failed this course automatically. You don't want to be in that situation, so no cheating at all. It's fine for you to discuss the homework with your classmates, but do not just copy and paste someone else's code, and also do not share your code with your classmates. It's going to put you and your friends in a dangerous situation. So so the policy is that, okay, the cheating or plagiarism policy is that if you are found cheating, you will automatically fail this course immediately. Okay, so and yes, this is the policy, and so here something more is that what can I help you with this class? So here I got my office hours, and in my lectures I will explain this materials in detail for you. Okay, and also I'm going to have a tutorial session next week to help you start the homework. And okay, here is the schedule of your homeworks. Okay, so if this is the Tuesday, this is a Tuesday, and then this is Friday. Okay, so because our lectures are given on Tuesdays, so you will have your homework. Your homework will be released on Tuesday, on Tuesday, and then the homework is going to be due on next Friday. So in total, you have 11 days to work on a single homework, 10 or 11 days to work on a single homework. And so, and also it is not me who grade our homework, rather it is we have a GA, grading assistant, to grade your homeworks. So usually I require the GA to finish grading your homework within 1 week of submission. So, but the situation is that if some students ask for extensions, or say some students submitted their homework late, usually the GA can only start the grading later. So then my bottom line is that you will get your grade within 2 weeks of the due date. So which means that you will be able to see your grade at this so on this date, 2 weeks after the due date. Okay, so now this is the tentative schedule of homeworks, and mostly importantly, I'm not the one who come to evaluate your programming skills. Rather, I'm the person who help you to improve your programming skills. So I'm come here to help you. It's pretty straightforward because you are paying the tuition to the university, and I get a share of your tuition. as my salary. So basically, you are my customer. So I'm coming here to serve you, not to judge you. So I'll be friendly with you, and we will respect each other. Okay. So before I go to the first algorithm, feel free to ask me any question if you have.
I got a question.
Sure.
I just noticed when I went to files, there's the first homework is available right now, and I wanted to know when it's due. Is it due the upcoming Friday or this Friday?
The upcoming Friday, next Friday.
The next Friday.
The Friday of the next week.
Okay. All right. I just want to know that. All right. Thank you.
I also have a question.
Sure.
I don't see anywhere to submit the homework. Are you gonna put that later?
You you mean that you don't see homework on Canvas yet?
Well, I see the homework. I see homework 1. I do see that, but I don't see where to submit it to.
Okay, yes, this is because I haven't released the homework yet. So by releasing, I need to create an assignment on Canvas. Okay. I'm going to do that after our lecture. So you will be able to see the first assignment on Canvas, even though now everyone can see the PDF of the homework, right? But I have to I'm going to create an assignment for you to submit tonight.
Okay, thank you.
Okay.
Hello.
Hi.
I have a question about the attendance policy.
Okay. What is your question?
Like, what's the attendance policy like?
Oh, attendance policy. Okay, sure. So in general, I don't want to be a one who forces the students to come. So this is because, say, if you don't think that you can learn anything from my course, from my teaching, then if I force you to come to my lectures, it will be a waste of your time, right? So how come that I ask you to waste your tuition and waste your time at the same time? So in general, I don't want to do a lot of attendance sheet, but I have to do some based on the university's requirements. Probably I'm going to do 2 or 3 attendance sheet, and especially in the first in this week. Next week. This is for the sake of the scholarship or assistantship for some students. So say my policy is that if I do 3 attendance and you miss all of them, then yes, I will have to say you. I will have to talk to you. Okay, but as long as you come to one of them, you should be fine. Okay, I don't want to force you to come.
Makes sense. Thank you, Professor.
No problem. And I see a question from the chat area. Will we have breaks? It depends. I mean, say if we have a whole topic, I would like to finish it consecutively without any stop, because if we stop, we have to spend more time when we come back. But say I know that 2.5 hours of lectures is very long. So and also it's a challenge for my throat, especially when we go back to face-to-face teaching, and I have to wear a face mask. At that time, I have to wear a face mask. Last semester, when I wear a face mask and talk, I couldn't breathe well. At the same time, I have to speak very loud in order for everyone to be able to hear my voice. So my throat was burning after 1 hour after the lecture. So what I want to do is that, say, I will try to finish our lecture in a short amount of time. Let's say instead of having 2.5 hours of lecture, probably we'll end with 2 hours or 1 hour and 45 minutes if we can finish everything on time. If we can finish everything, okay? And so if the session is longer than 2 hours, definitely we will have a break. Okay, so here is another question from the chat area. What software or IDE will we use to do the homework? I don't force you. I don't want to force you to use any. But personally, I recommend. I know that some people use JGrasp, some people use Eclipse, some people use Xcode. In general, I recommend Eclipse. I'm going to type the name of the say IDE over here is called Eclipse, and also I'm going to write it down on my iPad. I think most of you have at least heard about it before, Eclipse. So the reason is that I'm mostly familiar with this one, and I can teach you some debugging skills with this IDE. For the other IDEs, I rarely use them, so I cannot teach you how to debug in those IDEs. And so okay, so another question is, what programs should I download on my PC for the homeworks? Okay, same question. Yes, Eclipse, or if you want, you can just you are free to edit your code in a notepad or text edit, and then compile your code from the compile and run your program from the command line or terminal. Okay, so what else? Any other question? Yeah, feel free to ask. Okay, so I have two questions to you. Okay, so first, can you hear me clearly? I mean, I'm an immigrant, so I don't speak English very well, so I'm not sure if you can hear my voice and understand what I'm saying. Okay, thank you. So yes, thank you. And okay, I got one question. Say, I use Intel J, but I don't think you can download two IDEs that are Java. Should I uninstall and use Eclipse instead? No, you can install both of them at the same time. On my laptop, I have Intel J, I have Xcode and Eclipse. What kind of projects are we going to do? Are we going to be doing? It's going to be programming, and the topic is fixed. So I will release that to you later. Okay. So you don't need to worry too much about the project at the current time. Is the homework graded on correctness strictly or completeness too? So the thing is that if your program does not compile, it's very difficult for you to receive a high grade from your homework. Okay, if your program does not compile, it means that it's something like you write a letter. You write a letter with grammar errors. So even though your program cannot be executed, in that case, you can receive at most 60% at most. And then as long as your program compiles, and even though the output is wrong, the output is not correct, you can receive some partial credit, say, for example, 80%, 70%. So say if you are doing homework and you don't think you get the correct solution. So, and also the submission time or the due date is now. Just submit that, you will receive some partial credits. Okay. Any other question? Okay. So so let's say, do you want to take a break now, or do you want to continue?
Continue.
Before I go to the first algorithm.
I could go for a break.
Okay. and just get a poll. Add a question. That's a question. Okay. Sorry. Can you see the poll?
I cannot.
Okay, so let me say, how do I put that?
Yeah, I don't either.
Okay, so then I'm going to I just created a poll, but I don't know how to share it with you. Okay, so forget about it. So I can continue. Okay, so then probably I will let's just take a break for 5 minutes and because if I continue, it will be like until probably 7:30 or 7:40. So let's take a break for 5 minutes for everyone to refresh, and then we'll come back in 5 minutes. Is that fine? Okay.
Hello, Dr. Dong.
Yeah, he went somewhere, man. We had a 5-minute break.
Oh, I thought he was gonna stay in the Zoom. I knew we had a break, but normally the professor stays.
Yeah, I guess you went to go get a drink or something.
Yeah, it's fine.
Professor.
Oh, I mute myself. I'm sorry.
Yeah.
Okay, so
I have a question.
let's resume. Okay, is everybody back?
Professor, I actually had a couple of questions. So if we do have to go in person, you said to contact the disability center about health concerns?
Yes. So if you
Okay.
don't, yeah, because the university requires everyone to have some in-person experience if we go back to face-to-face teaching.
I
So
see.
yeah, so if you want to say if I know that someone has some health concerns or they have seniors at home, so then you need to go to the go to contact the disability center. This is the policy from the university. It's really complicated. I realized it only realized it like maybe 3 or 4 days ago. Yes.
So I was looking at your syllabus, and I know that you're strict with the grading policy. Like if you have a 94.9, that's an A minus.
Mhm.
But throughout the semester, will there be any curbs or extra credit at all?
No curve, but extra credit.
Okay. Thank you.
Yes, there will be 4 extra credit opportunity for you. So in total, so actually, I said that so if the overall grade is 100, so if we consider the extra credit, the max that you can earn is like something around 116. So
Okay,
there,
so we have plenty of opportunity to increase our
yes.
grades. Thank you.
Yes, and also if you want to know the grade, say according to my previous experience, say around half of the students can get A minus or A, and this is mostly because of the extra credit opportunity. And also I read so probably only like every semester if the only like 1% or 2%, maybe 2% of the students fail this class. Say if I teach in 3 sections in total, there are like 90 students. Probably in total there are only 2 students who fail this class, and those students who fail this class, most of them are like only submitted 2 out of 10 homeworks, and then there is no way for them to pass it.
Yeah, I noticed that you have only 1 exam instead of like 3, which is like more usual, I guess.
Mm-hmm.
So it's like the grade is like basically made graded on effort because of how many assignments we have.
Not efforts, like how it's yeah, you can take it as efforts, but it's like how do you perform, like how's your coding question, how's your coding problem solved.
I see.
Okay.
Also, could I talk to you after class?
Sure.
Okay, thank you.
Okay, so this is our first. So now I'm about to teach our first algorithm named insertion sort. But before that, I need to give 2 definitions, and these are the only 2 definitions that we're going to learn in the semester. The first is, what is an algorithm? So an algorithm is basically a computational procedure to solve a computational problem. So then what is a computational problem? So a computational problem is like a specification of the input and output. So for example, if we take the sorting, if we take the sorting problem as an example, the specification of input is a sequence of numbers, whereas the output specification is a reordering or permutation of these numbers so that they're in ascending order. So this is the sorting problem. So basically, if we for a problem, if we give the input, if we feed the input to an algorithm, we want the algorithm to work out the correct output. Okay, So here, I'm just going to give you one example. So suppose here we got an input instance for the sorting algorithm, which is a sequence of numbers, 31, 41, 59, 26, and 41 and 58. So what do you expect so if we feed this input instance to a sorting algorithm, what kind of output do you expect to see? What is the output that you want to see? If we feed these numbers, 31, 41, 59, 26, 41, 58, if we pass this input or this array to a sorting algorithm, so what do you expect the output to be?
Numerical order?
Yes. So we expect it to be something like 26, 31, 41, 41, 58, and 59, right? Yes. So this is the specification. So this is an example of say an input and output instance of the sorting problem, and in the first couple of weeks, in the first 3 weeks, we are going to focus on the sorting problems. And actually, so let me give you another example. So suppose that now I give you one problem, which is to go from, or one problem or one task, which is to go to Los Angeles from New Jersey. So what is the solution? What is your solution to the problem?
Go on the highway.
Yes.
Drive west. Drive west.
Yes, correct. So to solve the problem to go from NJ to yes, I see some answer like wrong. Yes, to solve the problem to go from NJ to California. Some of you may come up with a solution. Say, okay, I want to take a flight. And some of you may say, okay, I want to drive. And some of you may say, okay, I want to run. Okay. Yes. So as you can say that to solve the same problem, there can be multiple solutions. Again, in the computational world, it's the same. To solve the same computational problem, which is the sorting problem, there can be multiple solutions. We call each solution an algorithm. So there are multiple algorithms that can be used to sort an input array, an array. And so there are quite a few, and we're going to learn 4 different algorithms, which are insertion sort. Insertion sort. The second one that we're going to learn is called merge sort. And the second one is called, the third one is called quick sort. And the last one is called the counting sort. So in the first 4 weeks, we're going to learn, in the first 3 weeks, we're going to learn 4 sorting algorithms to solve the sorting problem. And each of them comes with an advantage and a disadvantage. And so we will also discuss them. So for today, our topic is just insertion sort, one algorithm to solve the sorting problem. So here is the introduction of the insertion sort algorithm. So people design this algorithm from the intuition of playing poker cards. Let's say here, for example, if we are playing poker cards, we want to get the cards in our hand sorted in numerical order, so that when we play it, we can quickly find which card that we want to play. So here we can take it as this. We can view it the following procedure. Okay, suppose here we already have 4 cards in hand that have already been sorted, so which are 2, 4, 5, 10. 2, 4, 5, 10. Okay, And now you got a new card from the table. You get a new card from the table, which is 7. So you are going to insert the new card into your hand, into the correct place of your hand, which is between 5 and 10. So that after the insertion, you got 5 cards in your hand, which are sorted. So in this way, previously say that before we do the insertion, we only got 4 cards sorted. And after that insertion, we got one more card at our hand. And so we got 5 cards sorted. Does it make sense? So the way that people design insertion sort is pretty much like getting cards from the table and playing poker cards. It's like initially our hand is empty. There is no card at our hand, so we just get 1 card from the table, put it at our hand. Then next we get a second card from the table, insert it into the correct place so that we got 2 cards in our hand. Then third card, fourth card, etc., etc. And if we think of this, imagine the numbers as the cards, we can follow the same procedure. By inserting those numbers into the correct place, we'll be able to sort. Finally, we'll be able to get all of them sorted. Make sense? So, okay. Here is the procedure for us to insert a new card into a sorted subarray. By subarray, we mean that a small a subsequence of the numbers which have already been sorted. So this is one example. But before explaining the example, I'm just going to show you something like this. Okay. So have you seen anything like this before?
Yes.
What is this card?
Sorry, what? What is what?
What is this format of program card? Yeah, I see the answer.
Oh, pseudocode. Yeah.
Yes, pseudocode. Yes, pseudocode. Great. So okay. So definitely, like you can say that this is pretty much like a code because we got a for. Obviously, it's a for loop, and we got while, and so okay, yes, but this is not a, if you fit this piece of program into a Java IDE, it will give you a lot of compiler errors, meaning that it contains grammar errors. Okay, so so the reason that we are going to use pseudocode in the class is this. Okay, so let me explain pseudocode to you if you are not familiar with it. So here we definitely know Java code. So here, so on the left we have human language, and on the right we have something like programming language. Like Java, like C++. So the programming language is used to, so our machines, our computers can only understand programming languages, whereas for humans, we are best at human languages. So if you want me to explain the previous procedure, like by inserting poker cards into the hand and get all the cards sorted, and so if you ask me to explain that procedure in the human language, it will be very short. Like every time insert a new card into the correct place. Yes, and so by keep doing that, we will be able to get all the numbers sorted. Yes, so it's very short and succinct, and everybody can understand it. But if we want to translate that process into Java code, or into a programming language that our computers can understand, it will be like 100 lines of Java code, roughly. Actually, it's like 80 something. But in order for us to explain it in human words, it's like human language, it's like 20 words. So here we can say that there is a big difference between the human language and machine and programming language. So human language is more succinct, but it's relatively abstract. Whereas programming language is definitely much longer, but it's more illustrative. So it includes every detailed instruction for us to execute. So here people just, so here, the thing is that if I explain insertion sort by using human language, it will be a waste of your tuition because it's not clear at all. You don't know the computational procedure to do that. Whereas if I show you a Java program of that, you don't even want to read it because it's like 100 lines of Java code. You don't want to read it. So people design something in between them, which is more detailed than human language, but which is shorter than programming language, and we call it pseudocode. Pseudocode is like a combination of human language and programming language. So that's why we have this. For example, like 4j, starting from 4j equal to 2 and to 8 dot length. So yes, so it's just in between. Pseudocode is just like a language in between human English and programming language. So it's shorter than the programming language. Okay, and in our class, my task is to explain the algorithm by using pseudocode, and my task in class, our lecture will be focusing on the pseudocode. Okay, pseudocode, and so I'm going to use pseudocode to explain why insertion sort can actually help us to get a sequence of numbers sorted. And after the class, your homework, your task is to translate this pseudocode to Java. Okay, so basically, that's why I say in my lecture, we are focusing on understanding the algorithm by using pseudocode, and then after the lecture and your homework, it is your task to translate that into practice your programming, improve your programming skills by translating the pseudocode to Java program. Okay, here I just got one question is asking me, is the homework due tonight? No, it's due next Friday. So for every homework you have around, it's going to be released on Tuesdays, and it's going to be due on the Friday of next week. Okay, so here let's go through the pseudocode over here, and we got insertion. So here we got the first line, which is insertion sort A, a bracket, a pair of brackets with A inside it. So do you know what does this stand for? Or if I ask you to translate this into Java, how are you going to translate that?
It's a function with a parameter.
Yes, great. This is a function declaration, right? Function declaration. It's like we're going to declare that we're going to define a function with the name as insertion sort and with the input as the capital A. So when we're when we're dealing with sorting algorithms or sorting problems, we're only going to deal with array. So the capital A is basically an array of integers. Capital A is basically an array of integers. So if we want to translate this line into Java, it will be public. So here it seems that this function does not return anything. So we just define the return type of it as void, meaning that we don't want this function to return anything. And then insertion sort, I'm just going to use lowercase letter instead of the capital letters. Insertion sort, and the input parameter of this function is an array of integers named capital A, whose variable name is capital A. So this is how are we going to translate the first line of the program into Java, correct? So any question with this?
No.
Okay, okay, great. So next, let's look at some more lines. So next we have 4j equal to a dot length. So tell me, what is this? How are you going to translate it into Java?
For loop.
Yes, for loop. I hope that everyone can realize this is a for loop. Yes, this is a for loop. So we're going to have a for loop, and so the way that we are going to call it is translate is that, okay, for integer j, we're going to create a new integer j whose initial value is 2, and j is so the maximum value of j, according to the specification of the pseudocode, the maximum value of j is the length of the array, correct? So we're going to write it as j less than or equal to the length of the array. And then j plus plus. So by default, even though this pseudocode does not specify that every time we are going to increase j by 1, by default, we so in the pseudocode we assume that so in every loop we are going to increment the variable by 1. So that's why we have j plus plus. That's which means that in every iteration of the for loop we are going to increase j by 1. Make sense?
Yes.
Okay, cool. So okay, and then let's look at the some parts of the pseudocode. So key equal to a j, and then we got another line, okay, with double slash. Insert a j into the sorted sequence a1 dot dot j minus 1. So what is this line for? What is this line?
Just a comment.
Yes, comment. Great. So this, if a line starts with double slash, it means that this line is a comment. It's like we put a note in the program. So this line is not going to be executed by our compiler, our Java compiler and virtual environment. Instead, it's just a note for us. So and then I equal to j minus 1. Next, we have while I is larger than 0 and ai is larger than key. So, and then we have ai plus 1 equal to ai and I equals to I minus 1. So, so what is this? What is the what is this part? What is this part?
A nested loop?
Yes, a while loop, right? This is a while loop. Correct. And then after we finish this while loop, we have ai plus 1 equal to key. Okay, equal to key. Okay, so this is the pseudocode. And before before I go to the details of the pseudocode, I'm going to I need to talk something about arrays, the array indexes. And let me just create one extra, add one page over here. Okay, so I'm going to write an array. Let's say we have some values 4, 1, 3, 2, 6, and 5. Okay, so here say we just create an array. So capital A with 6 numbers in it. And so tell me, in Java, what are the indexes of these elements in the array?
0 through 5?
Yes. So in Java, the index that we're going to use is this. So 0, 1, 2, 3, 4, 5, right? So meaning that in Java, so the array index starts from 0. Okay, so here if we say, okay, we are going to call system dot out. If we call system dot out dot print line with A0, okay. So what is the value? What is the output that we are going to see? Yes, we're going to see 4. Yes, because A0. So by calling A0, it's going to retrieve the elements whose index is 0 in the array, and the value that it's going to retrieve is just 4. So that's why it's going to print out 4. So for us, right? Okay, great. So this is the index system in Java, and actually the array index system in Java, actually there are a lot of languages following the same convention by using the index starting from 0. Okay, so some languages besides Java are like C++ and Python. So in these programming languages, by default, so they assume that the array index starts from 0, okay? Whereas there are some other languages which use a different convention. For example, Scala. So in Scala, they assume that the index starts from 1. The index of the array starts from 1. And also there are some other languages. So if you know Pig, there is one language named Pig. So it also the array index also starts from 1. So I mean, this is just like different conventions, and so but our textbook, the textbook that we're using, so it follows this convention. It assumes that the array index starts from 1 rather than 0. Okay, so which is different from Java. So this will give you some trouble when you are doing your assignment, because you cannot just translate the pseudocode line by line directly. It's not going to work. I'm going to show you why it doesn't work. And actually, it requires you some critical thinking to figure out how to change the code from the convention by which uses where the array index starts from 1 to Java, where the array index starts from 0. Okay, so you cannot just translate it line by line, translate it from pseudocode to Java program line by line. And they require some critical thinking. Make sense? Okay. So so next I'm going to so throughout the semester, as I said, in my lecture, my task is to explain the pseudocode to you. So in our lectures, we will assume that the array index starts from 1 rather than 0. Okay. So so next, I'm going to use one example to go through this piece of code line by line. So again, I'm going to create another page and write down the pseudocode over here. Next, I'm going to write down the pseudocode over here. So I'm going to write down the pseudocode. Insertion sort A for J starting from 2 to think of the array. And next we are going to have P equal to a J and I equal to J minus 1. And then we're going to have while I is larger than 0 and AI is larger than key, we are going to have a so we're going to have a I plus 1 equal to AI. And we're going to have I minus minus. And then we are going to have AI plus 1 equal to P. Okay, so this is the pseudocode. I'm just writing it over here, and then I'm going to create one example on the right hand side. So with our array A, so whose numbers are like 524613. 5, 2, 4, 6, 1, and 3. Okay, here we have our array A, so with 6 numbers in it, and the index of these elements are 1, 2, 3, 4, 5, 6. Okay, so again, here we use the index starting from 1 because the text will follow this convention, and so let's go through. Let's say, okay, we just have the an input instance, the array A with 6 numbers in, and then we are going to pass this input instance to the insertion sort algorithm, and let's go through these instructions line by line together. So first we have for j starting from 2 to a dot length. So here, tell me, what is the length of the array? What is a dot length? What is this value, a dot length?
Number of items in the array.
Yes, which is
5.
No, 6.
No,
here we
6,
got
sorry,
6
including
numbers,
0.
right?
Including
Yes.
0, yeah.
So even though we use we follow the index, follow the convention where the index starts from 0, the length of the array is still 6, correct?
Yeah. Mm-hmm.
Yes. So okay. So we know that the starting value of j is, so here we just create an integer j. So whose initial value, I'm going to use another color, probably this, we have j, initially we have an integer j whose initial value is 2, and we can increase it as to as large as 6. And next we have key equal to aj, okay, key equal to aj. So if I ask you to translate this line into Java, what is the corresponding line in Java? We're going to do this, okay? So we're going to write this line as int k key equal to aj, correct? Over here, correct?
Yeah.
We're going to create a new integer variable, and its value is aj. So yes, here we're going to create. I'm going to list all the variable values over here, okay, for our references. So for key equal to aj. So here we have j as 2. What is aj?
2.
What is aj? Yes, 2. So because j is 2, we are going to get a2. A2 is right over here, which is a2 is right over here. So it is 2, correct?
Yes.
Yeah. Mm-hmm.
Okay.
Yes.
So starting from here, ask me any question if you have immediately. Okay. So I don't want to lose anyone. So here I'm going to, because here you can say that we're going to use j as the index of the array, correct? We're going to use j as the index of the array. So I'm going to mark j over here, meaning because the j's value is 2, so I'm going to put j. I'm going to use j as a pointer to the second place of the array. Okay, so basically based on the value of j, it's going to point to the corresponding place in the array. So here we got aj as, because j is 2, so because j is 2, so we have aj over here, which is also 2. So we have key as 2. And the next, we are going to say have I, the next line that we're going to execute is I equal to j minus 1. So, so how are we going to translate this one into Java? How are we going to translate? Okay, yes. Not j minus minus, not j minus minus. It's going to be this. Integer I equal to j minus. Okay, I see why you say. Now I understand why you say j minus minus. It's because of my writing. This is I, and so on the left we have I, on the right we have j. So it's not. If it's j equal to j minus 1, then it will be j minus minus. But here it is I equal to j minus 1, so it will be something else. Okay, so this is the corresponding line of Java code for this statement. So we're going to create a new variable, integer variable whose name is I, and its initial value is j minus 1. So tell me what. So here we're going to have a new variable named I. What is the value of I? I is going to be j minus 1, right? What is j? What is the value of j? 2, right? Here we have j as 2, so it is going to be 2 minus 1. So the value of I is going to be 1. Yes. So I'm going to write it shortly. So it's going to be 1. Okay, so we have I equal to 1, right? And then we have next we have the while. We have the while statement. So it's basically a while loop with this while I is larger than 0 and AI is larger than key. So tell me, if this condition is true or false, is I larger than 0 true or false? True, right? This is because I is 1. So 1 is larger than 0. This is true. What and something else. AI is larger than key. What is AI? What is AI? No, not a 1. AI is not a 1. Yes, 5. Yes. So here, because here you can also see that we're going to use I as the index of the array. So similarly, I'm going to put I over here because the value of I is 1. So I'm going to point I to the first place of the array. And so AI is just right over here, which is pointed by by I. So the value of AI is 5 because A1 is 5, correct? So let me write it down slowly. So here AI is basically A1, and A1 is 5. So this is 5. So this is 5, correct? AI is 5. What about key? What is the value of key? What is key? Yes, 2. We can refer to the variable table over here to say that okay, it is so it is basically 2. Key is 2. So let's say here on the left hand side we have 5. On the right hand side we have 2. So is 5 larger than 2? True or false? True. So okay, so this is also true. So true and true is true. So while true, we can continue. We can execute the statement inside the while loop, right? We can execute because the condition is true. We can execute the statement over here. So next we will have this AI plus 1. So we are able to execute this line, which is AI plus 1 equal to AI. So what are we going to do with this? Are we going to compare AI plus 1 with AI? Are we going to compare these two values to check if they're the same or not? Yes or no? I say one yes. No. I say two no. Oh, three no. Okay. Yes. No. So if no matter it's in Java or in C++, if we want to compare if two values are equal or not, A equal to B. If we have this, okay, if we have two integers, integer A equal to 5, integer B equal to let's say 2. So if we have A equal to 5, what is the result? What is the result? The result is that we are going to
A equals to
assign,
2.
yes, we are going to assign the value in B, where basically we're going to assign the value in B to A, right? So the value of B is 2, so we are going to assign 2 to A. So now A gets a new value, 2. This is the result. So instead, if we want to compare the equality of two values, we need to do this: A equal double equal B, right? If we do double equal, this will be false because they are not the same, correct? Are you still with me? Okay.
Yep.
Cool. I wish that I have a real whiteboard so that I don't have to switch from these different pencils, okay? So yes, okay, then let's come back here. So here, basically, we're going to retrieve, this is, if we take it as A equal B, the assignment is pretty much like we are going to retrieve the value from B and assign it to A, right? Similar here, we're going to retrieve the value from AI and assign it to AI plus 1, right? So what is AI? Tell me, what is AI? What is
Isn't
AI?
it 2? Isn't
5.
It's 5.
Yes,
Wait,
5.
but I thought since the index started at 0,
No, as I said, in the lecture, we are going to assume that the index starts from 1 to be consistent with the book.
I see.
That's why we got this.
That was actually confusing me a bit for a while.
Okay.
Because from CSIT 112, the index started at 0.
Yes, because Java assumes the index starts from 0. But here, as I explained before, there are some languages like Python and Java, which assume that the index starts from 0. But there's something else, some other languages which assume that the index starts from 1. And to be general, our book follows this convention.
I see, but when we're doing so I understand what you're saying, and like if that's an assumption I'm going under, then I'll just do it that way. But when I'm writing code in Eclipse, I have to do it the other way.
Yes, you have to go back to the Java.
Yeah. Okay.
You assume that the index starts from 0.
Okay, that clarifies my question. Thank you.
No problem. So here we're going to retrieve the, let's go back here. We're going to retrieve the value from AI. So here we know that AI is 5. AI is 5, so we will assign as 1. What is I?
I is 1, and
I is 1. So it's like us. Yes. Right? iteration. First, I is greater than 0 or not. So this is, and our condition
No.
is true or false. No, so it will automatically be false. Be false automatically. So here, so this is going to be false. Okay, so meaning that we are going to end the while loop, right? We finish the while loop. We cannot continue the while loop anymore. Correct?
Correct.
So we're going to go to the last line with AI plus 1 equal to key. So let's say what is the key? What is the value of key?
2.
2, yes. According to the variable table, variable reference table, we have say key as 2. And what is I plus 1? What is I? Let's be slow. What is I?
I is 0, and then I plus 1 is 1.
Yes, I plus 1. This is 0 plus 1. In total, it is 1. So it will be A1. We assign 2 to A1, right? Okay, so here we just assign 2 to A1. We give it a new value. Okay, so let's say over here. Okay, so here we finish one iteration of the for loop. Okay, and let's look at the array. So in the array, because j is 2, so when we finish this iteration of the for loop, we got the first 2 numbers sorted. Correct?
Correct.
Yes. So in this one, we got the first 2 numbers sorted. And next, so I'm going to ask you one question, okay? After we finish this line, where should we go now? Which line should we execute? Yes, we should go back to the for loop. Yes, because this is one part of the for loop. So after we finish one iteration of the for loop, we should go back to the for loop again. So when we originally we have j equal to 2. So now we should increase the value of j by at the end of this for loop. We should increase the value of j by 1, right? So j has a new value 3, and we are going to move j. We're going to move j to point to 3, correct? And then, so we have next, we have this key equal to aj. So what is the value of key now?
4.
Yes, 4, because j is 3. J points to 3, so a3 is 4. Okay, and what is I? What is I?
2.
Yes, I equal to j minus 1, which is 3 minus 1, and it is 2. So here, let me make a stop. Let me stop a little bit and ask you one question. So what if this is like we're playing playing poker cards? What does key stand for? What does key stand for? What is key like when we are sorting the poker cards?
Key is the 3rd card.
Yeah, key is the 3rd card, or basically key is the new card that we got from the table. So the situation is now is like we got 2 cards in our hand, which are 2 and 5, and then we got a new card which is 4, which is we use key to store the value of the new card, which is 4. And now our task is to find the correct place to insert the new card 4 into our hand. Make sense?
Mm-hmm.
Okay, so next we are going to do that. So I'm going to have I point to, because I is 2, so I'm going to have I point here. So next, let's check if the loop, the loop, we can execute the for loop, while loop or not. So is I larger than 0 or not?
It's larger than 0, yes.
Yes, this is true. And AI is larger than key. So let's say, what is AI?
4.
5.
Um,
I is 2.
yes, you're right. Sorry.
Here I is 2. So AI is 5, right? And what is key?
4.
4, yes. So is 5 larger than 4?
Yes.
True. So true and true is also true. So this condition is satisfied. So then we can execute the statements inside the while loop. So then we are going to this line. We have AI plus 1 equal to AI. So first tell me, what is AI?
5.
5. AI is 5, which we just figured out over here. AI is 5. What is I plus 1?
3. So
Yeah,
A3
3.
is 4.
Yes. So this is like A3 is 4. Sorry, A3 is 5. We assign 5 to A3, right?
Yeah, but it used to be 4.
Yeah, it's used to be 4, and now we give it a new value, 5. This is pretty much like this, okay? So here, let's say what we are going to do with it is this. It's like we are going to assign 5 to this place. We're going to assign 5. We're going to assign 5 to this place, right? And then we're going to execute the next line and decrease I by 1. So the new value of I will be, sorry, the new value of I will be, originally we have I equal to 2. So after minus minus, I will be 1, right? So
1.
And then we are going to move I from 2 to 1 to point to first place of the array. Okay, so we have I equal to 1. And next, so now we finish one round of the while loop. Where should we go next? Which line should we execute next?
AI plus 1 equals key.
No. We should go back to the while loop, right? Because we just finished one iteration of the while loop. We just finished over here, and we should go back to the while loop to see if this condition is satisfied or not. If yes, we should continue executing the 2 statements over here, right? Right? Yes. So then let's go back to the while loop again and check if it's true or not. So here, let's say we need to check if I is larger than 0 or not. So this is true or false?
True.
True, because I is 1. 1 is larger than 0. So let's check the second condition, okay? What is AI?
False. 2.
Yeah, yes, AI is 2. This is because I is 1, so AI is right over here, it is 2. And what is key?
4.
4.
Or wait, sorry.
Is 2 larger than 4?
No.
No, this is false. So true and false is false, meaning that the condition of the while loop, it fails. So we have to terminate the while loop and go step out of the while loop and go to execute the last line. We have AI plus 1 equal to key. So what is key?
4.
4. And what is I?
1.
1 plus 1 is 2. So this is like we are going to assign 4 to A2, correct?
So the second index becomes 4.
Yes, the second index becomes 4. And the second value of the array becomes 4. So so now we finish another iteration of the while loop. And after this, we finish another iteration of the for loop. And at the end of the for loop, we got the first 3 numbers sorted, correct?
Yeah.
Yes. So this is like, so let's recap what we did before the beginning of the so at the beginning of the for loop. At the beginning of the for loop, we have the numbers that we have in our hand are 2 and 5. This is our hand, and then we get a new card, which is 4, correct? So the first 3 numbers are basically 2, 5, 4. right? Right?
Mhm.
And this is like we have two cards in hand, which are 2 and 4, and they are sorted, and we got a new card. So after we get the new card 4, and we first compare it, we first compare 4 with the last card at hand, which is 5. And we find that 4 is smaller than 5, which means that 4 should go before 5, right?
Correct.
Yes, 4 is less than 5, so 4 should go before 5. So to allocate space for 4, we move 5 one position to the right. That's why what we do over here in the first iteration of the while loop, we assign 5 to A3. So we assign 5 to A3. So here we got we move 5 to one position to the right, and next we compare after that we compare 4 with 2, and we say that 4 is larger than 2, right? So then we know that 4 should go 4 should go after 2, correct? Mm-hmm. So then we just put 4 right at this place. That's how we reach 2, 4, 5, and get the first. So by inserting, so this is like by inserting 4 in between 2 and 5, we got the first 3 cards. We got 3 cards sorted, right? Yes. Any questions so far? Is that clear?
And so okay. For the next for loop, J is 4, key is 6, and I is 3?
Yes, okay. Correct. Okay, thank you for your responses. I see a lot of responses, and this makes me feel confident. So here I'm going to remove these lines, and I'm going to do one more iteration. So in total, there are 6 iterations, but I'm only going to do one more because of the time limit. So so here, sorry, this is still 6. This is still 6, and what I'm going to do is to get rid of this. So we finish another iteration of the for loop, and so we just end up over here. We just end up over here, and where should we go next? Where should we go next? Which line should we execute next? Yes, for loop. So we go back to the for loop. So previously we have J as 3. Now we are going to increase J to 4. And we have, so I'm going to put J to 4, okay? And so what is key? What is the value of key? Yes, key equal to 6, and I equal to what? What is the value of I? Not 5, it's 3. 4 minus 1 is 3. Yeah, okay. So and the next we are going to check if the condition is satisfied or not. Is I larger than 0? This is true or false? True. I is larger than 0 because I is 3. What about AI? What is AI? Oh, sorry, I forgot to mark I over here. What is AI? AI is 5. And what is key? Key is 6, according to the value table. K is 6. So this is false. True and false is false. So we are not going to execute it. So yes, the while loop terminates without even start. So then we are going to execute the last line in the for loop. And with so here we're going to have AI plus 1 equal to key. So this is like so what is key? 6. And what is I plus 1? So what is I? We got I at, we have I as 3. So 3 plus 1 is 4. So this is 4. So this is like we assign 6 to A4. And so it's like we are going to assign 6 to this cell. It's just remain unchanged basically. So here you can see it interpret this iteration as in this way. Okay, previously we got 3 cards at hand, which are 2, 4, 5, and then we got a new card 6. So after we got the new card 6, we compared with the largest and the last card at hand, which is 5. We found, okay, 6 is larger than 5, so we just insert 6 after 5, which is pretty simple. Okay, and at the end of this iteration, we got the first 4 numbers sorted, right? And here, if we continue to the 5th iteration and 6th iteration, we'll be able to get all the 6 numbers sorted. So I'm not going to illustrate those iterations. If you are interested in that, you can do it by yourself after the class. Okay, so do you have any question? And also from here you can see that at the last of the iteration, when j reaches 6, we'll be able to get the first 6 numbers sorted, right? So this is how insertion sort works. How does insertion sort work? So any question regarding the logic of insertion sort, or if you don't understand why insertion sort can help us to arrange the numbers in an ascending order, just read the question in the chat area. Okay, so if not, then I'm going to show you the pseudocode. Okay, this is the pseudocode, and this is here is the different iterations of the example. So this is what this picture is provided by the book, and actually I think the value of this of my lecture is that so compared with the book, the value of my lecture is that I will show you how does it work step by step, rather than just showing you a couple of images like this. So I hope that you enjoy my lecture and keep coming to my lectures. Okay, so next, so I think now at the current time, everyone understands how insertion sort help us to sort the numbers. But next is that if you implement insertion sort by yourself in Java and present it to your boss, say for example you work in an IT company, and you implement insertion sort and then present it to a boss, and your boss say, okay, great job, you got all the numbers sorted with your insertion sort algorithm. But how fast is your algorithm? How long do you expect your algorithm to run, your program to run? Then what is your answer? Think about it. How are you going to reply your boss?
Probably start with pseudocode.
I don't. Actually, no. You don't have to go through the pseudocode. So your boss just want a simple number. Just want a simple answer rather than a piece of pseudocode.
What was the question? How long is my algorithm gonna last?
Yes.
Until it gets the job done.
So some of you may say, okay, my algorithm may run for 1 second, or a few minutes, or a few hours, right?
I see. Okay.
Yes.
Well, I think like the IDE has a clock, like it tells how many seconds. Maybe we could just tell what the IDE says.
Yes. Yes, so you may say, okay, you may just record the time based on so basically you can just say get the time running time of your algorithm and report it to your boss. But but what you can say but what you will observe is that, okay, basically I'm going to write to draw a plot. So on the right, the y-axis is the how long does your algorithm take, and then on the x-axis it is n. So where n is the length of the array. So in general, you can expect the length of the array. So in general, you can expect that if you want your algorithm to sort a very long array, it will take longer time, and if you want it to sort a shorter array, just for example, one number, it's going to be very fast, right? Much faster. But instead, if you want your algorithm to sort, your program to sort 1 million numbers, it may take a few hours, correct? So basically, the execution time of your code or your algorithm depends on the size of the input. So in the sorting problem, the size of the input is just like the number of elements to sort, or so how many numbers do you want to sort? So if you record the execution time of your program at different, so you may say, okay, if you want to sort 10 numbers, it's very fast. If you want to sort, let's say 100 numbers, it's going to take long. It's going to take this long. I'm going to take this long. If you want to sort, let's say 1,000 numbers, it's going to be like this long. No, let me make a better example. So for 20 numbers, it's this long. 30 numbers, it is this long. 40 numbers, it is this long, right? So we can basically get a plot with regard to, okay, so the execution time of your pseudocode with regard to the size of the input, right?
Mm-hmm.
Okay, and then you will be able to get such a plot. Yes, I already see some answers in asking if this is exponential, and actually this is, I mean, so if you think about it exponential, it means that at least you are very sensitive to math. That's pretty good. Okay, so here, so we usually use complexity. We use the term complexity to describe how fast is your algorithm. Complexity means that how fast does the time grow with the length of the array or the size of the input. So for insertion sort, in the worst case, it is this O(n) squared, meaning that the execution time grows quadratically with regard to the size of the input. Meaning that, so in general, you can expect that, okay, so if the input size is 10, and say, for example, this is the time. So for example, if your algorithm, if it takes 1 second for your algorithm to sort an array of length 10, it can take up to 4 seconds for your algorithm to sort an array of size 20. This is because the execution time is going to grow quadratically with regard to the input size. Awesome. Okay, I got a question asking me. So in the best case, the algorithm complexity would be constant. Awesome. Yes, the best complexity that we can hope for is constant, meaning that no matter how long it is, your algorithm is going to take constant time. The time will not be affected by the size of the input. That is the best we can hope for. And in general, we want this. And so in terms of constant time, we give it a term named O(1) because the complexity is the running time is totally irrelevant to the input sizes. So in general, we're going to use an mathematical formula, n square or something to express how long does your algorithm. How long is the running time going to grow with regard to the input size? So for insertion sort, it is O n square. And here we use the letter capital O to denote worst case. Worst case. So this is because to sort an array of size 10, if you got to sort two different arrays, let's say we got array A, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is already sorted. It's going to be very fast. If we got an array B, which is inversely sorted, 9, 10, 9, 8, the last number is 1. Even though they have the same size, it may take only like 0.1 second for array A, but 1 second for array B. So in computer science, we care most about the worst case. How long? So for a certain n, how long is your algorithm going to take at most? That's what we call worst case performance. Okay, so and worst case performance, and here we use big O to denote worst case complexity, meaning that in the worst case, your algorithm, the execution time of your algorithm is going to grow quadratically with regard to the input size. Okay, does it make sense?
Yes.
I know this is. Say it.
I feel like in all my computer science classes, I've never had an algorithm that took like more than 1 second. So I just wasn't thinking about an algorithm that could take hours, like in machine learning, for example.
You are going to have your first algorithm, which takes more than 1 minute, in your first homework of our course.
Oh wow! Okay.
Yeah. So everything. So the execution time of your insertion sort depends on the input size. Okay. So if it's very long, it is going to take a very long time. Okay. So so here, with regard to the time complexity, some of you may feel lost. I know this is very abstract because it's highly related to math, but I require everybody to at least memorize that the complexity of insertion sort is O n square. So because you are going to be asked such questions in your future job interviews. Okay, and also for every algorithm that we learn in the semester, we're going to talk about the complexity. So this is like if some people design a car, everybody is wondering how many horsepower or how long does it take from 0 to 60 miles per hour, right? So the complexity is pretty much like that. Okay. Yes, factoring would be the complexity of factoring is exponential. So which is even higher than the n square. So we're going to discuss that later. Next, I'm going to talk about your first homework. Okay, so so for any insertion so I got one more question. For any insertion sort algorithm, the time complexity will be always O n square. So so let me give you an example like this. Okay, so for example, if we talk about the speed of cars, so let's say if you got, for example, if you got a Honda Accord, so when we talk about Honda Accord, so people may say, okay, this car comes with maybe 185 horsepower, right? So So basically, for every Honda, we say that okay, it comes with this much of horsepowers. But your question is, in the best case, it has 185 horsepowers. But does every Honda Accord have that horsepower? Not actually. So because if you have a car with a so whose engine which is like 5 years old Accord, you probably only get 160 horsepower. And if you got a 10-year-old Honda Accord, it probably only comes with 150 horsepower, right? So that's a bit high for Honda, but it doesn't matter, okay? So my point is that when we talk about the horsepower of the Accord, we say 185. That is the best case, meaning that when it is brand new. And here, when we talk about time complexity of an algorithm, if we use the big O notation, big O means that the worst case. Big O means the worst case. Basically, in the worst case, if you are really unlucky, you are going to get this. If you are going to get n squared time complexity, but if you are lucky enough, for example, if you fit an array whose size is 0.1, whose size is 10, but it is already sorted, well sorted, it may be much shorter. So here, we just use big O to let people know, in the worst case, how slow will your algorithm be. Okay, does it make sense? Okay, so next I'm going to talk about your first homework. So I already posted your first homework on Canvas. So in the first homework, you got two tasks. The first task is to implement the insertion sort algorithm, and I already give you some pseudocode. So and next, and so after you implement your insertion sort, I want you to draw a plot like here. So where the x-axis is the number of atoms to be sorted, and the y-axis is the time. How long does your algorithm take? So I'm just giving you one example of the plot, but when you draw the plot, you only you only have one line, not 3 lines. Here, in this example, it has 3 lines because it has three sorting algorithms. But here, in your first homework, you're only going to implement insertion sort. So you are only going to have 1 line like this. Okay, so I want you to draw such a line. To draw such a line, there are a lot of tools. For example, you can use Excel to do that. Okay, you can use Excel to do that. And next, I'm going to say turn off my iPad Pro, and I'm going to use my laptop to explain you the pseudocode that I prepared for you. Okay, so I'm going to present from my laptop.
So just one question, Professor.
Sure.
You said O(n) squared was the formula, and n is the array length. What was O for? What was O? What does the variable stand for?
It stands for the worst case time complexity. Okay, here I'm just showing you the code that I just wrote today. So that's how I brush up my coding. And these are the plots that I draw, some machine learning stuff, but we're not going to talk about machine learning in our course. And here I'm going to open up Eclipse for you. Sorry, my laptop is burned by me, so it's super slow. It's very slow. Is this the Eclipse that I'm pushing on? On the left-hand side, it is the code that I yes, this is the. Can you see my screen?
Yes.
Okay, so this is the skeleton code I provided for you. So I don't, to be honest, I don't expect you to be able to fully implement insertion sort by yourself because you are going to deal with a lot of things. And so I provide this skeleton code for you, and you only need to work on this part called insertion sort. And here I have the comment for you called fill in your code for your program. Basically, you are going to translate the pseudocode to Java program. And this code, this is a static function. It will return the array. And I help you to implement some auxiliary functions. For example, to generate a random array of a certain size. N is the size of the array. Generate a random array of certain size. Basically, it will, and then help you. I implement another function called check sorted to check to help you to check if an array is already sorted or not. And here is the main function. So in the main function, what it does is that first it say, okay, it print out a line saying that insertion sort starts, and then for n starting from 100,000 to 1 million, every each iteration for later, maybe tomorrow. I don't think I can get it right today. I think it seems that it works now. Let's say videos. Okay, wait a second. Okay, so my Zoom seems come back. Seems that my Zoom is back. So I'm going to share it with you. Can you see it?
Yes, we can see it.
Okay, so if you execute this code, so this is the output that you are going to see. So can you see it? Can you see the output?
Yes.
Yeah.
Okay, each line basically includes three different elements. The first element is how long is the array. So we can say that the array to be sorted starts from the length starts from 100,000 to 1 million. And then the second number is how long does your insertion sort take. So right now it is all 0 because we don't have anything in the insertion sort except for just returning the input array. So, but after you finish implementation, the implementation of your insertion sort, these values will not be 0. Okay, in the second column it will not be 0 at all. And so the last column is all false because the last column will be either true or false. If it's true, it means that the array is already sorted. It means that your implementation of insertion sort is correct. Otherwise, it will be false. So to check if you get your insertion sort correctly implemented, you want to see the last column to be all truth rather than false. Make sense?
So I ran the code. Where do you see how long it takes to run it?
In the second column. Now
Okay.
it is all zero because we don't do anything in insertion sort. So it's a super fast, zero millisecond. But if you just implement your code over here, and it will now be zero. So this is how long it takes. The second column will tell you how long it takes. Does your insertion sort take to sort an array of the length in the first column. So for example, if the first row is 100,000, 100, it means that it takes 100 milliseconds to sort an array of length 100,000. Make sense?
I see. Yes, that makes sense.
Yes, so this is, so after you collect these numbers, you can just copy and paste them into Excel and draw a plot by using Excel. And so that you will be able to get that plot.
So the professor, so the first number is basically the length of
the length of the array.
elements of the array, yeah.
Yes.
So it's basically gonna, so the second number is basically gonna go up because it's just
yes. It should go up.
Okay. Could I use something that's not Excel, like a mathematical application on the internet?
Of course, you are more than welcome to do that.
Perfect. Thank you.
Okay. So, okay. Any question?
No.
Okay.
Not about this, but I did want to see you after class.
Okay, sure. So we can talk after class. And anything else you want to ask? Is there any general question from the class? If not, then it will be the end of our first lecture. Okay. So yes, have a good night, everyone.
Good night, Professor.
Thank you.
Good night, Professor. Thank you very much.
Thank you.
Bye.
Okay. Hello, Dr. Dong. So
Hi.
I'm pronouncing your name correctly, right?
Yes.
Okay. I was a student that emailed you, I think it was months ago, like when registration first opened, about if the class was going to be in person or not. I mean, that has nothing to do with it. I just wanted to mention that. But so I'm starting a data science master's in the fall, but I also I want to pursue a PhD in economics, and I'm already taking 7 classes. So I dropped Python to take an econometrics class, Python 2, CSIT 114. Is that really necessary to get into like a data science master's, or can I because I know you learn Python in the master's program anyways. So
I would suggest you to learn Python.
Yes.
Even though you want to do your PhD in finance or economics. Yeah, it's a very powerful tool, and as far as I know, those guys in economics, they also use Python to do data analytics.
Yeah, I really, out of I know 3 languages: C++, Python, and Java. Out of the 3, Python is my favorite. It's just like the simplest, and I know it's used a lot in data science. I just don't know if it's necessary to take the class at Montclair. I feel like I could learn it on my own.
Oh, if you could learn it on your own, then yeah, feel free to drop it.
Okay. Yeah, I was just nervous that it might decrease my chances of getting into a data science master's. So that's why I was a little hesitant to drop it. But
no, you don't need to. I mean, but actually it depends on where where do you want to do your master? If you want to do your master in data science at Montclair, it's almost guaranteed that it will be admitted.
Yeah, well, I'm not I'm applying to Johns Hopkins, Northwestern, University of Virginia, University of Michigan, and Stevens. Those are the 5 schools.
Cool. Yeah, you can. So because I think you have a good chance.
Oh, okay.
Yeah.
Thank you.
No problem.
Your lecture was informative.
Thank you. Thank you.
Have a good day. Have a good
You
night.
too. Bye. Have a good night.
Bye.